Hello everyone and welcome back to the Kohi Game Engine series. Today we're going to be tackling something that we're going to wind up needing for our UI system, our world editor, all kinds of different things. And that is going to be object picking. And we're going to implement one method of object picking. There's a couple of ways to actually handle this. So object picking is basically when you click an area on the screen with your mouse, whatever is below that mouse, you should be able to select. So in the cases of UI, it might be a checkbox, a radio button, a scroll bar, something like that. In the case of a 3D scene, it might be some mesh that you have in the scene or some entity that you've got in the scene that you want to be able to select. And so there are two main schools of thought in terms of the way that we can actually handle this. The first one of those is you typically would, at least for world object selection, you would typically leverage the physics system that you have in place, which we don't have yet. And basically you would unproject that particular mesh back to screen space, then compare that with the mouse position on screen. And you would essentially undo all of those operations so that you could just work in screen space coordinates, and you would essentially cast out array and say, hey, what does this actually hit? And that's a gross oversimplification of that. But that is actually not the method that we're going to be implementing today. We are going to be implementing that at some point. But for today, we're going to do one that is going to be a little bit more useful right away. And that is going to be what we're going to call pixel perfect object selection. And so what we're going to do is anything that should be selectable will have some sort of unique identifier. In our case, it's going to just be an integer identifier. And that integer identifier is going to be translated to an RGB value. And then each object will be drawn using a special shader to the screen. Using a different color. So if I just go ahead and create a new image here, I've just got this open in GIMP, right? So we could say, for example, that we have, an object that looks something like, make it a little bit bigger here. So let's say we've got an object over here that maybe its RGB identifier translates to blue. And then we've got another object that's actually in front of it that overlaps it a little bit, right? And it's got this pinkish sort of color that its ID translates to, right? And so when we were to hover our cursor over the screen and actually select a particular pixel, if you recall here, we had this blue object that sort of went behind here like this, and then we have this pink object here. How does it know which one to actually select? Well, it just goes by the color of what's been rendered to the screen. So it takes the RGB value, basically converts that back to an integer, which then we can use as our object ID internally, and we know what object we actually have selected. And so this is the method that we're going to be using, and this will be a lot more clear once we actually get to implementing this. So this is just a sort of rudimentary example of what we're going to be doing. What we're really going to be handling here is we're going to have the very close colors to one another because these objects IDs obviously are going to be, 1, 2, 3, 4, things like that. And so the colors are going to look very similar, but they're actually going to be ever so slightly off. And we're actually going to crank up RenderDoc and look at the result of that once we get this in place. But for now, that's the basic premise of what we're going to be doing, is we're going to be creating what we're going to call pixel perfect object detection, or object selecting, rather. And so the first thing that we're going to do is I mentioned the need for a special shader. And so we're actually going to have two variants of this shader because we're going to be using this for the UI layer, but we're also going to be using this for the world layer. And for now, these shaders are going to be almost identical to one another, with the exception that one takes 2D vertices and the other takes 3D vertices. They may diverge at some point, so I'm going to go ahead and separate them and create them as separate shaders. Okay. So I think the first thing that we need to do is we need to come up here to our shaders, and we're going to create basically 4 files. So I'm going to create a new file. I'm going to call this built-in. Oops, built. We'll call it, we'll do the UI one first, so we'll call it UI pick shader. We'll do the fragment one first, GLSL, okay? And for expediency, I'm actually just going to copy this whole thing. All right, actually I'm just going to create all 4 files real quick. So we have the fragment one, then we have the vert one, and then we're going to go ahead and create another one. And this one, instead of UI pick shader, it's going to be, we're going to call this one world pick shader. So that one is going to be, I'm just going to copy the name of that, create a new file here, and we'll create the vertex shader. Okay, so like I said, we're going to start with the UI shader variant of this first. So this is going to pretty much be very similar, like a lightweight version of what we've already seen. So the real difference here is our local uniform object is just going to contain the ID color. So we're not going to do the conversion to color in the shader. We're actually going to do that before we pass that information over to the GPU. So by the time it gets here, we're just going to have a RGB color. So we're going to call that our ID color. And all we're going to do is just take in a model matrix. And then here we're going to go ahead and, in fact, I actually don't need this here. I think I only need that in the vertex shader. So actually, yeah, I can get rid of that. I don't need this guy. Okay, so we can actually simplify that. And so we're basically going to say the out color is this UBO ID color with an alpha of 1. And that's it, right? It's a super simple shader. There's nothing much to it. So as you may expect, the vertex shader is also really, really simple. So it also is just takes the view, projection, and model matrices, and then just draws the geometry as is using those things. So nothing too fancy there. It just, in this case, takes the same layout as our 2D vertices. So in this case, and position and texture coordinate. We're not actually using the texture coordinate, but since we don't want to create a new vertex layout for this just yet, I'm going to go ahead and treat it this way. Okay, so that is the UI pick shader. The world pick shader is going to be almost exactly the same thing. So again, we'll start with the fragment. And again, I don't need this push constant here, so we can actually get rid of that in this case. All it's going to do is, again, take a ID color and output that. And that's pretty much it, right? Again, we could have technically used this same file for both, but again, they might diverge at some point, so I'm not going to do that. And then, of course, we have the vertex shader, and it is going to be basically the same thing as the UI version of this, only it's actually just using our vertex 3 layout, which has all this other information. Now, like I said, an optimization here would be to clean up this data and have a lightweight type that only contains positional data, and maybe we'll do that if we determine that that's actually going to save us some resources. But in this case, I'm not really going to worry about it just yet. Okay, so obviously we have 2 shaders, so that means we need to create new shader config files as well. So in this case, it's going to be shader.builtin .ui pick, dot shader config. And I'm just going to copy this, and I'll go ahead and create the one for the world as well. So I'll call this world pick. Okay. And again, we'll start with the UI pick one. And this should be pretty much everything that you expect it to contain. So this looks a lot like the other shader configs that we've seen. There's not really anything special here. It's just pointing to our fragment shader and vertex shader files, right? And those are the compiled versions, so we'll have to remember to go ahead and build those as well. So we have one for the the UI pick. And then, of course, as I mentioned, we are also going to have one for the world pick. Okay, and so that's what that looks like. Again, nothing too crazy here. I do want to mention that I'm kind of alluding to it here. There is going to be a render pass specific for this, so we're going to be creating one of those as well. But again, that's not a huge deal, right? So that is pretty much it for the shaders, at least. However, we actually need to hook this into our build system. So we're going to come down here to our post build. Right here, we'll start with the batch file. So for the Windows version of it, and we just need to add 4 lines to this. So right below our skybox, we're going to add for our UI pick shader, vert and frag, and our world pick shader, vert and frag. Okay. And so obviously, since we're doing that for the batch file, we'll need to do that as well for the bash script for the other platforms. So we're just going to add those in there as well. Okay. And that should be it for that. So actually, before we move on, I'm going to go ahead and run a task post build. And we see here that everything looks like everything built successfully. So we should be good to go in loading those things. So let me just make sure. Here's our SPV files for those things. So we're good to go. Okay. So the next bit of this is we're basically going to have to create a new render view and hook that up. And that is really where the meat and potatoes of all the changes that we're going to be doing is. So before I do that, though, there is one tiny little bug that I actually need to fix. So in event.h, we have the mouse move event. Where is that mouse move? And right here, we are actually using a U16 here. This actually needs to be an I16 because on Mac OS, if you have the window sort of in the middle like this and you move it out here, this would technically be a negative coordinate over here, but it still actually gets registered with the window. So in order to cover our bases on that, we are going to convert this to an I16, and that should still really cover us in most scenarios in terms of resolution. We can bump that up to a 32-bit integer if we need it, but for right now, I think 16 bits is just fine. So we need to change that there, and then we also need to go to input.c. And we'll need to have a look here at the input process mouse move. And instead of referencing the U16 here, we are going to reference the I16 here. And we see that we are actually using I16 here anyways. So we really should just be doing that here as well. Okay, and that is, I believe that should fix any issues that come up with that. Okay. So, like I said, there's a couple things that we actually need to set up. Most of our changes are actually going to be in the application and the view itself. So I think the first thing that I'm going to do is start creating what we need for the view. With that said, actually there is one more thing that I did need to fix in renderer front end. So in the render pass destroy, there was one thing that we forgot to do here. So we're calling render pass destroy, but we actually didn't destroy the render targets, which is going to be an issue. So we should be destroying those render targets that exist on that pass. So we just go ahead and add this here, and that'll go ahead and make sure that those resources get cleaned up as well. Next change we're going to make is in render types. So we'll go here to render types INL, and then we're going to check out the render view known types. So we'll say render view known type. Okay. And we're going to just add a new type to this list. So right after Skybox, we have a new one here, which is for pick. And this is a view which only renders UI and world objects to be picked, right? We're gonna wind up handling both of these scenarios at once, okay? So that is it as far as that goes. And then if we go down here to our UI packet data, where we've defined that, we actually need to make another packet data type. So right put it right before our Skybox packet data, we'll go ahead and declare our new type here. So this is going to be a pick packet data type. And this structure is basically going to hold the information that we need for our pick render pass to render out that image that we're going to select from. And so what this is going to have is it's going to have world mesh data and geometry counts and mesh packet data and UI geometry counts, right? So this is going to be basically reusing the structures that we already are using for the UI packet data and the world render data pass. And then we're also going to have some temporary data in here for our UI texts. We are going to be revisiting this once we have our UI system in place to not have to have this hack. But for right now, we need a way to go ahead and render UI text so that we have a way to pick that out of the scene as well. All right. So that's it for the render types that we need to add. And now we can actually move on to the view itself. So what I'm going to do is come down here to our renderer and then views. And I'm going to add a new file here. And I'm going to call this render view. Why have you done that? Okay, I'm not sure what just happened there. Let me try that again. All right, render view, and we'll call this pick. And this particular render view is going to handle the rendering of world objects and UI objects for our render pick pass. So it's going to be a separate render pass that we're going to have that handles all the pick stuff all in one go, right? And that'll make it easy for us to sort of pick out where this stuff exists. So this is what the interface for that looks like. So we have our typical on create, destroy, resize, everything here that is absolutely needed for us to be able to implement the render view interface. Okay, so there's not too much craziness here in terms of that. So I'm going to go ahead and move on to the C file. So it'll be render view pick.c. And this is going to be kind of a big file. Not huge, but big enough, we'll say. And so I'm going to go ahead and drop in the includes first. So we're going to need all these things for this view in order for it to work. So logger, memory event, strings, our UID, our math library, transforms, D-array, our resource system, shader, camera systems. So you can see that this sort of interacts with a lot, right? And it actually interacts with our UI text as well. So we need all those things. And what we're going to do is we are going to have a structure that we're going to use for the shader info. And the reason I've declared this structure here is because remember we have two shaders. We have one for the UI and one for the world. And so our properties for both of those things actually wind up being the same thing. We have basically a color location, model location, I should say model projection view location, a projection matrix, a view matrix, clipping planes, etc. Right? And so this is a list of properties that both shaders are actually going to need. And so we've gone ahead and wrapped that up in a structure. Next, our view is going to have internal data just like our other views do. And so we have one of those shader infos for the UI, one of those shader infos for the world. We have a texture here. So this is our color text, our color target attachment texture, right? So this is going to be a texture that we're going to create for our color attachment. And this is the first time that we're actually going to be rendering to a texture using our render textures that are not basically the swap chain, right? Aside from the depth buffer. So in this case, we're going to be creating a texture and managing a texture on our own that we're going to be using as a render target. And we're going to draw to that texture and we're going to read from that texture in order to apply our picking. So in this case, we have our color attachment texture here, and then we also have a depth attachment. Now, temporarily speaking, we are going to have a separate depth attachment texture that is going to be separate for the one that's used for everything else. And that is because, in this case, we are going to have a different subset of objects eventually that are going to be rendered to this that aren't rendered to the rest of the world. And so we want the ability to have a different depth buffer available for just this view to use. So we've got that. We have an instance count. This is basically an instance for shader instance, or a material instance, if you want to think of it that way, for our shaders. So we have whether or not that's been updated. So we have an array of those for the instance count. And then we're also going to keep track of our mouse X and Y. So the first thing that we're going to do actually is we are going to, I think, let's see. Let's go ahead and implement the create method first. And actually, I'm just going to drop this in all at once, and then we'll sort of walk through it little by little. So our render view pick on create obviously is going to allocate our internal data, create our instance updated array, and that's just going to be a D array. And we're going to go ahead and get the render pass, right? So we have, as this says here, basically a heavily customized view. So we know how many render passes we're actually going to use. And so we can actually hard code these indices, and that's just fine, because this is always going to work a super custom, super specific way. We don't need to be generic about it. So anytime you can get away from being generic with stuff, it's generally faster to do so. So here's the built-in UI pick shader. So this basically just loads that up, loads up the resource, creates the shader, goes ahead and extracts the uniform locations for that, sets the default properties for it, including an orthographic matrix and a view matrix. And then it goes ahead and does the same thing for the built-in world pick shader, following all the same steps. So we get the uniform location and the default properties. We also zero out the instance count, and we'll sort of come back to that in a minute as to how that works. We also go ahead and zero out the target for the color and depth attachments. And then we go ahead and register for two events. So we first register for the mouse moved event. And obviously that means we're going to need an on mouse moved function to be called. And then we register for the render target refresh required, which, if you recall, was something that we set up in the last video, and we're going to be leveraging that here. And so this, of course, has its own callback as well. If all that succeeds, it returns true. And then here, if anything, basically self is not available, or is a null pointer, then we bleat about it and return false. So before we move on, let's go ahead and get our on mouse moved and our render view on event. We're going to go ahead and declare those up here. So I think it's okay to go ahead and just leave these here at the top. So here's our on mouse moved. It checks the code, goes ahead and gets the internal data, and then reads the event data here. You see that we're using the I16 type, or we've done that before, and then goes ahead and just sets the mouse X and mouse Y in our data to that. So all it does is just updates that, right? Doesn't really do anything fancy. And then, of course, we have our render view on event, which is handled a little bit separately. So in this case, it goes ahead and gets the self from the listener instance, which was passed when we actually subscribed. And then, of course, bleats about that, or returns false if that's a null pointer for some reason. In this case, for now, the only one that we're going to handle here is the event code default render target refresh required. And so this is basically just going to call our render view system regenerate render targets. And then this event needs to be consumed by other views. So we're going to return false here to say this has not been handled. Okay. And then, of course, if we get any anything else, we're just going to say, hey, we also didn't handle it. Okay, so that is that. All right, so the next thing that we have is we've got our create. So down here, right after that, we're obviously going to have our destroy. And this basically just unregisters from the events, releases any shader resources that we have, which is something that we actually have not defined yet. So we'll have to go back and define that. And then we destroy our render target textures. We free the internal data and then zero it out. Nothing too fancy there. Next, we have the onResize event to be handled. So we have that here. So we go ahead and get a pointer to our internal data, just as we always do. Set the width and height. We regenerate the UI shader projection matrix just by creating a new orthographic matrix. The world, we go ahead and regenerate its projection matrix. And then we loop through the render passes that we have, and we set the render area to that. Now, I should mention that if this is ever not a full screen thing, this is going to be an issue. But for now, I think it's fine to make this assumption. We can always refactor this later if we need to. And so that is the onResize. Now I think, let's see. So I think before we actually move on, I want to go back to the top here, and I want to add two more things that we're going to need, because we've already sort of alluded here when we destroy that we're going to be releasing shader instances. And so we need two more sort of private methods that I'm going to create here right above the onCreate. And we're going to have one for acquiring shader resources and one for releasing. So we'll take care of the acquire first. So this basically is going to say, for this particular view, we need to acquire instance resources. And the instance ID itself here doesn't actually matter because this data is regenerated and reused every single time. So we don't actually have to maintain any sort of state here. We just have to have a number of shader resources acquired for the number of objects that we're actually drawing. So the order of those objects doesn't actually matter the way this is done because it changes every time anyways. So in this case, we have just the instance being, sort of stored off in a local variable here that gets thrown away because we don't care about it. And what we're going to do is we are going to go ahead and acquire instance resources, saving that there, which again gets thrown out. We're going to do the same thing for the UI and the world shader. And then we're going to increase the instance count and push it into the data instance updated array. And we're going to say false. And so basically what that's going to do is it's going to maintain this array of Booleans here, right, as to whether the instance has been updated for that particular instance ID, and it's going to start off at false, right? And this is the total count of that. And so what we're technically doing here is this is going to be called anytime we are rendering a UI object or a world object. And so technically we should never run out of resources because we're technically increasing this once every single time. Now, we do check this instance count to make sure that we need to even call this whatsoever at all. Because if we don't, obviously we're not going to call it. So that's the reason we keep that. Anyway, so that's the reasoning for that. And then we have our acquire, and of course that means we need our release, which is there. That does exactly what you would think it does. It just basically goes through our instance count and releases everything. So this acquire shader instances basically only goes through and acquires once. However, release is everything. So basically once we acquire instance resources, we don't release those until we actually destroy the view. That's the way this works. So this release shader instances goes through the entire thing and releases everything, then destroys the D array. Okay, so now that we have that, we can go ahead and move on to the rest. So the last thing that we did was our resize here. So we are going to come down and after our resize, we are going to implement our build packet. And this looks like a lot of code, but it's really not that complicated. Okay, so I'm just going to drop it in here all at once and explain it. So we do some sanity checking, get our packet data here casted cold casted packet data, our internal data pointer here. We go ahead and create a geometries array. And again, this is dynamic allocation every frame. Eventually, we are going to have a frame allocator that's going to handle this for us. That's going to speed that up a little bit for us so that we don't have to do this every frame off of our sort of generic allocator. But that's an optimization that we're going to do in the near future. So next we have, obviously with the view itself, we set that up. I have a to-do in here to get the active camera. We're just going to get the default because we don't actually have a concept of an active camera just yet. You'll recall that the world view actually does the same thing. So this goes ahead and gets the camera. And then we go ahead and start setting up the packet data, which is our pick packet data here. We go ahead and get the highest instance ID. So basically this is just a running counter that we keep every single time we iterate. So we go through all the meshes in the world data. We say, okay, we grab a pointer to that mesh, we loop through its geometries, and then each one of the geometries, we go ahead and prepare it and push it, just like we do in the world view. And then what we do is we count all the geometries as a single ID. So we say the highest instance ID is basically the unique ID here, okay? And since these are generated typically in order, we can go ahead and rely on that. Next thing we go ahead and do is we do the exact same thing for the UI data. So that's that. We also count all of our texts as well. And so we go ahead and keep track of that as well. And then our required instance count is the highest instance ID plus 1. And so what this does is it says if our required instance count is greater than the instance count that we have, then we go ahead and find out what that diff is. And then for the amount that we need, we go ahead and acquire shader resources. Yes, there's probably a faster way to do this. For now, I'm not really too worried about it because once you've rendered out a few frames and you've got a pretty complicated scene loaded up, you're not going to really be doing this all that often anyways. It's really one of those things that once it gets stood up and grows to a certain size, you're not really going to be calling it all that often. So once that's done, we just return true to indicate success, and that is building the packet. So again, it looks like a lot of code. It's not really that crazy. Of course, we have a destroy packet. All that does is call darray destroy for the packet geometries and then zeroes out the memory. So the next thing is going to be the onRender. And the onRender, again, kind of looks like a lot of code, but it's really not that complicated, okay? So I'm going to go ahead and slam this in here all at once, and we'll come back and look at it. So, of course, we get our pointers, we get our render pass, which in this case is the render pass P is 0, so we start off at the first pass here. If the render target index is 0, right, then we do all of this stuff. If it is not, we skip a lot of stuff, okay? And that is because we are only going to be actually performing this pick on every essentially third frame because we don't really need to do this every single frame. And in fact, eventually we probably won't be doing this even every third frame. It'll probably only be on a click. But for the sake of being able to hover over objects and see the currently hovered over ID, which is that property that we added into the application before, that is what this is for. So every third frame, essentially, we're going to be running this code. So the first thing we do is we reset the instance updated flag for the entire array to 0 or false. We go ahead and begin the render pass. We go ahead and cast the packet data. We do the world first because the world should be rendered first, then the UI. So we handle this just like our sort of system that we already have set up here. We're just rendering this to a different target using different shaders essentially, but the process is very much the same. So we do the world first, we apply our globals, right? And then we draw our geometries. So we're going to start from 0 since our world geometries are added first, and then stop at the world geometry count. So we see here that we're iterating from 0 all the way up to world geometry count. So I think that was a detail I actually forgot to mention. So I'll come up here. And so within our render view build packet, all of the geometries go into the same array. So we're taking all these world meshes, and these are all being added to geometry. So we add those first. We keep this running world geometry count here. Okay. And then what we do is we iterate all the UI meshes, and we're still adding those to that same geometries array, but we're incrementing the UI geometry count, right? So that's a separate counter. And so that allows us to say, okay, everything is jammed in the same array. We only need one array to be created. And then we can come down here in our draw, and we can actually iterate those objects individually. So we can start with the world by going from 0 to world count, do everything that we need to do to go ahead and draw that out, this is pretty much exactly the same code that is in the world view. And then we can end that render pass and come in here for our second pass. So we increment P and we say, okay, well, here's what our pass is now. We begin the second pass. This is our UI pass, right? So we use the shader, apply globals, and then loop through those geometries for the UI. And instead of starting at 0, now I starts at world geometry count. So we start at the end or after the end of those world geometries, and we say, okay, well, I needs to be less than the packet geometry count, which actually, wait a minute, that's a bug. So this should technically be the difference between those two things. So as long as this is less than geometry count, yeah, that should be, let's call this UI count. And we're going to set that equal to world geometry count plus packet geometry count. And we'll use that instead. Right, and that should get us to the end of the array. Right, okay. I'm glad I noticed that now. Okay, so anyways, we loop through those, do the exact same stuff that we do in the world array. The only difference is, and I actually should have pointed this out up here, is there is one extra step here. So we get our color based on the ID. So if you recall, we added this unique ID, right, to each of our geometries. And so what we do is we call our U32 to RGB, and this takes that unique ID and converts it to an RGB 0 to 255 range. Then we take that and we convert it to 0 to 1 float range, and then we go ahead and we set that uniform, right? So I missed explaining that before, but everything else is exactly the same, right? So we do that for our world, and we do that for our UI. So our UI is done right here. Okay, so it's the same process for both. Now, my dog just keeps randomly barking in the background. That's great. So after we do that, you know what? Let me go close the door. Hold on. Sorry about that. Okay. So once we've done that, then we basically follow the same process again for bitmap text. The bitmap text, again, gets a color based on the ID. The bitmap text also has a unique ID on it as well. And so eventually we'll come up with some sort of decorator or interface to be able to handle this a little bit more robustly than just having to tack on this unique ID to every single thing that we want to render. But for now, this will work, right? We're still building. So we do basically the same exact thing for our bitmap text. We apply the locals, and then we call our UI draw text, right? So this is all stuff we've seen before. The only real different bit is this. Finally, we end that render pass. And ordinarily, this is where we would stop, right? This would be the end of rendering for the view. But this view, again, works a little bit differently. So now we've actually drawn to this image. We've drawn everything, each object having its own individual color to our image. How do we then say, okay, we have our mouse position. What is under our mouse position currently? So to that end, we actually need to go ahead and read back the image that we just drew to go ahead and read the pixel data on that image, to then extract, the color that is underneath the mouse, and that is how we're going to get our ID. So first, we grab a pointer to the texture. We go ahead and we read the pixel at the mouse coordinate, right? So we have an array of 4 U8s, so we get an RGBA out of that. And then we're just going to go ahead and create an alias of this, basically. So we're going to have a U8 pointer to a pixel, and that's going to be the address of the first of those 4 pixels, okay? So we have this. It starts out all zeroed out. Then we go ahead and we clamp the coordinates to the image size. So where I was talking about, we can potentially have a situation like on Mac OS where we maybe mouse outside of the window and we're up here and we have negatives. We need to go ahead and clamp to the actual window because we're not going to be able to use anything that's outside that range anyway. So we go ahead and clamp on the X and Y axis. And then we call our renderer texture read pixel. And this is something that we had put into place, I believe, in the last video. And then we have the ability to extract the ID from the sampled color by basically reversing the operation that we did when we actually drew it out. So our RGBU to U32 takes our RGBA pixels, right? So we have our pixel 0, 1, 2, 3, and 3. And we basically have the address of our identifier here, right? And so we say if the ID is equal to 0xFFFFFF, this means that it's pure white and the ID is going to be invalid ID. That means we're not hovering over anything, right? So the image is cleared to pure white, and then we take that to mean that we are not currently hovering over anything if we are hovering over pure white. And then we go ahead and fire off an event with the hover ID changed, and the context here, which has a U32 that contains that ID. Now, granted, again, we are firing this off every single time we do this. We don't really need to do that. We could just cache this in here and only fire it off when it actually changes. And that might be the way to go. But for right now, I'm just going to leave it like this just to see it working, okay? All right, so we're getting close to the end of our view here. There is one more method we have to actually create, and that is to actually set up the render targets regeneration. So in this case, we have a custom function that we're going to use for the regeneration of the render targets. Okay, and so here we have our view itself, the render pass index, and then a pointer to the attachment itself. And this will say, okay, if it's a color attachment, then the attachment texture is going to be the address of data, color attachment texture. Otherwise, depth is going to be pointer to that texture, okay? Otherwise, we're going to bleat about this and say, hey, what are you doing, guy? This is rubbish, and return false to indicate a failure there. If the pass index is 1, meaning we do not need to regenerate for both passes since they both use the same attachment, right? So remember, this has 2 render passes in it, one for UI and one for world. But we only are using the same attachments for both passes. So we actually do not need to generate this twice. We can just do it once. So the first time this gets called, it'll be called against the first render pass index 0, and that'll pass this test. And then the second one will be 1, and then it'll fail that test because we don't actually need to regenerate it twice. We destroy the current attachment if it exists. So obviously the first time we call this, that won't exist yet, so it won't have anything to destroy. Here we go ahead and we set up a new texture. So this is where we use our UUID. And all we do here is we create a texture name that is a UUID. We just do that to generate a random texture name, right? We don't really care what the name of the texture is. It just needs to be random, okay? And then we go ahead and we get the width and the height from the pass configuration and the render area Z and W respectively. In this case, this does not have transparency. We could make this configurable, but I don't ever really see the need to use the alpha channel. At least I don't see it yet. But I don't want to make that assumption that we'll never use it. So I'm going to go ahead and put this in here with a to-do to make it configurable. Then we have our ID for the texture, obviously. And in this case, since we're not having the texture system manage this for us, we are going to manage it ourselves. We're going to assign it a invalid ID. We're going to give it the texture type of 2D. We're going to copy in the name of that, the width, the height, the channel count is 4. Again, this could be configurable. I don't think we're ever going to use anything different than RGBA, but maybe we will one day. The generation is going to be invalid ID, again, because it's not really something that we are ever going to really do much with, right? In terms of, where we're using generation to determine, if a texture is changed or whatnot, right? This technically will be auto-incremented every time we write to it, so it's fine to start with invalid ID here. It doesn't really matter. Our flags, however, is going to indicate that it has transparency, right? And then we're also going to say this is writable. We're going to say if the attachment type is depth, then we also need to add the texture flag depth as well. We're going to zero out the internal data for now, and then we're going to call our renderer texture create writable for that. All right, and that is our render view pick. So like I said, it seems like a lot of code, but it's really a bit of a repeat of some things we've already seen so far, with a little bit of new stuff kind of sprinkled in between it. So it's not anything crazy. Okay, so the next thing we need to do is we need to go to our render view system, and I believe the only thing we need to actually modify in here is the C file. So I'm going to do that, and I'm going to go here to the top, and we obviously need to add in our new render view here. So I'm going to add that right below Skybox. So our render view pick, and then our I did notice our actual system shutdown here is actually not doing anything, which is wrong. So we're going to go ahead and add in some shutdown code here. So we're going to destroy all the views in the system. Now, currently, this isn't affecting us because we're dealing with things that are destroyed by the swap chain, but our new textures that are created as part of our view will not have been destroyed when we go to shutdown, so we'll get some validation errors if we don't do this. So really, this should have been done all along anyways, but now it's basically just looping through each one of the views. If that view is has a valid ID, then it calls the onDestroy for that view, destroys its render passes as well, and then everything should be cleaned up at that point. The only other thing we need to do is come down here where we really need to eventually put in our factory. But again, for right now, I'm just going to go ahead and slam in our new function pointer assignment. So if our config type is renderer view known type pick, we're going to go ahead and assign those function pointers here. Okay. So again, this is the only one that's going to use our regenerate attachment target. Everything else here has zeros for that, but this guy actually implements a custom one. Okay. So that is, I believe, most of what we need to do outside of the actual application itself. So let's go to application.c, and we'll come down here. Let's see, I think it was somewhere right around here. So we have our world view here. So what we really need to do is right below that, there's our UI view. So basically right here. So we've created our UI view right there. We need to actually go ahead and set up our pick. So what I'm going to do for this is I'm actually, again, going to slam in all this configuration here, just because most of this is pretty self-explanatory. But this is the configuration for our render view for the pick pass, okay? So obviously we set the type here. We call it pick. We set up the matrix source. We have 2 render passes here. So we set up an array for that. Here is the world pass. So we have the render pass built-in world pick. We have the render area, clear color. We are clearing to white here. And I have here that this is a hack for us to be able to clear for better visibility. We should be clearing to black because 0 is an invalid ID. So we're actually not going to be using 0 as an ID here. So ideally, once we actually have this working and we're able to test it and verify that it's working successfully, and we don't need to visualize it, we can go ahead and set this to black. But for right now, I'm going to clear this to white, so that way it's a little bit easier to see when we go ahead and crank up RenderDoc what's going on. So our clear flags, we're going to clear the color and depth buffers. Here's our depth and stencil information. Here is all of the attachment information. So we have 2 attachments for this pass. We have the color attachment here, and then we have the depth attachment here. Present after is false on both of those, obviously. Here is where we set up the attachment arrays for those things. And then we have the next pass, which is the pick pass, which again has a clear flag of white, but this does not actually clear because this is drawn on top of the previous pass's output. And so in this case, we have just one attachment. So we have the color attachment, and then we have the attachment that's obtained from the view. We go ahead and store it so that we can be so it can be sampled afterwards. That's that section that after we've drawn to it, we need to actually sample it. If we did not store this, we would not be able to actually sample it. Okay, so we need to make sure that that's stored. And then we go ahead and set up the attachment information on the target itself, and then set up the target. And then we go ahead and call the create for that. And so this should actually be, instead of UI pick view, it should just be pick view, okay? All right, so that is that. There are a couple of other modifications that I want to make just to sort of make things a little bit more obvious as to what's going on. So I think down here a little bit where we are actually creating the test geometry that has our Kohi logo in it, I'm actually going to move it and rotate it a little bit just to sort of illustrate what exactly is going on. So right after, let me see, where is that? So here's the geometry. So right after here, right, I'm going to go ahead and move it and rotate it some. So we're going to set up a quaternion. We're going to rotate it by negative 45 degrees, and then we're going to go ahead and apply that to the transform of it. And then we're going to need to actually go into the application run and make some modifications within the game loop itself. So first thing, we have our view count here, which is 3. We're going to up that to 4 in both of these places, okay? And then a little bit further down, what we're going to do is we have the skybox, the world, the UI. We have some information here that's being, that's taking our mouse information for us, our FPS. All those things have already been added in. So once we do that, here's the UI packet. Here's where we build that. So right before we do end temp here, we are going to put in the construction of our pick packet. And there's not too much to that, thankfully, because for right now, we're just going to use the UI packets, mesh data, and world data, right? So we're going to use the data that we've already generated for these previous passes. Now, Eventually, we're probably going to want to sort of filter that down to only objects that we actually want to render that are picked or that should be pickable. Because there's going to be plenty of things that we should not be able to pick out of a scene or on the UI that shouldn't be clickable or pickable, right? And so eventually we're going to want to filter that, but for now, this is fine. We're just going to use it as is. So this goes ahead and sets that up and then builds the packet. The only other thing that we need to add in here is within the shutdown section. So we need to make sure that we shut down our render view system, which we actually had missed before. So I'm going to do that right before the geometry system shutdown. We just need to make sure to call this as well, because that was also not being called. That got missed earlier. Okay, so I'm going to go ahead and I'm going to clean, I'm going to build, and I'm going to run task and post build just one more time just to make sure that we're good. And I'm going to go ahead and run. Let's go ahead and run, see if we missed anything. And it seems that we did. So let's first and foremost see if we actually missed anything in our shaders. Output not consumed. Okay, so that's fine. Did we have any errors here in the console? I don't think we did. Okay. So we have a segmentation fault. Okay, geometries exists, right? Internal ID. Oh, geometry is a void pointer, or a null pointer rather. Okay, so let's take a look at the debugger and see if we can figure out what we missed. Draw geometry. So this is the fourth geometry that it's drawing. Oh, this is probably... I wonder if I still got this wrong. Let me kill this. Let me actually put... Let me put this back. So I think I had... Oh, I know what it was. Okay. I misread this. This actually wasn't a bug. Ignore this. Okay. So this is actually looking at the total geometry count. That was correct. I was thinking it was a bug because I was thinking it was the UI geometry count. And I'm like, well, how did that ever work? But that's actually not the case. It's the total geometry count. So this goes starting from the world geometry count to the total geometry count. So at the end of the list. Okay, so that should fix it. So we'll run again. And there we are. Okay, so I'm going to back up a little bit here. And in fact, let's just hover over some things here. So we see we have our Kohi logo up here. And we've got this none here. And if I actually hover over this, we can actually see 1, right? And one thing that you'll notice is actually if I'm hovering over this text, it sort of comes in and out. And that is because it's actually drawing these individual glyphs sort of with spaces in between them. So it's a little hard to select that exactly. So this one down here has an ID of 1. This one here has an ID of 3. So we see we're getting a different one there. This is also 3 because that's part of that same object. This up here is 9. This is 4. This one's 5. That one's 6. Let's see if the depth testing is working. I should not be able to get either of those through here, and we don't. So we can't actually hover over those until we get here. Okay, so this appears to be working. Let's go ahead and load up the rest of this scene here. So we've got something a little bit more complex to look at here. So our car here is 7. We have 8 back here, which is this whole Sponza scene. This whole thing is actually one object ID, which is not typically the way you build a scene, but because we're actually loading this as one giant object, it counts as one giant thing. And we see here that our depth sorting is actually working correctly. So even if we were to, sort of back up a little bit here and just leave our mouse sort of at this level here, we can see that that ID down there changes as we sort of hover over different things. Even though we're not moving the mouse, we can see as the cubes rotate and whatnot, we can see that those different IDs are coming up because those are what is currently under the mouse. So this all looks like it's working pretty well. Okay, so looks like we have some validation errors though. So what did I miss shutting down? Looks like we have some buffers that are not being destroyed. What buffer? Memory. I wonder if that happened to shut down. Let me run this one more time. I have a suspicion of what might have happened there. Nope, we still got it. Okay. So it looks like there is a... Looks like there's a buffer and then some device memory that's not being freed. Did we not... I bet that's here in this... I bet we're not destroying something here in this view. So... Because I think the only place that we're actually using... I think the only place that we're actually using a separate buffer would be for this read pixel. But that shouldn't be... Okay, well, I will fix that one off camera. I'm not gonna stretch this video out just to fix that issue. I'll probably fix that one and then we'll add that fix in to the next video. But I did want to go into render doc for a minute. Let's see, where was that? So in my case, I have render doc 1.18. So let me just cd into that. I think it was bin. And then I want to run q render doc. Okay. Let's see. So we've got that. We want to launch the application. I still have my last settings here, so I'm just going to do that. And I'm going to launch this. And I just want to show you guys kind of what we are working with here. So let me back out a little bit. And I'm just going to take several saves here. Because remember, we're not actually generating... hold on a second. Okay, and I'm back. So what we're going to do is we're going to take a look at the very first frame here. So we'll just double click on that. We see here that we have multiple passes, right? So we have our first three passes that we've had up till now. And then we have our pass number 4 and pass number 5. So this is going to be our world pass here, and this is going to be our color pass. If we go ahead and take a look at the resource inspector. Okay, so if we take a look at our first color pass here, we have our color pass number 4. This is our UI. If we take a look at the 2D color attachment, for each one of these draw calls, we see a new piece of geometry appear, right? And so these are our individual cube objects that are in the world, right? So we have these three things, and if we hover over this, we can see when we actually take a look at the color by right-clicking and holding, we can see here that our RGB differs slightly, right, between these two. So that's how we can actually translate that back to a number. So it looks exactly the same to us by eye, but it's not, right? If we take a look at this value right here, so this is our RGB. If we take a look at that, it's 0.1569 there. And if we move over here, this is 0.01961. So it's ever so slightly different, right? And so if we go into our next pass here, we will then have our UI objects drawn on top of it. So there's our rotated Kohi. Here's our text down here, which you can't really see all that well. And then our text up here. And so you can see if we hover over that, we get different color values yet for those individual pieces, right? And so that is basically how this works is we just hover over a certain part of the screen. We say, what's the color below that? If it's white like this, where it's all ones, then we're not hovered over everything or anything at all. Otherwise, we have something to translate back into an ID. Okay. And that is basically it. That is pixel perfect object detection or picking implemented in Vulkan. So this is one of the ways to handle that. And we'll be exploring how to use this in depth in the very near future. So that is pretty much going to do it for this video. Thank you guys so much for watching. I really appreciate you guys. And, we will go ahead and pick up on the next one. So I look forward to seeing you guys in the next video. If you haven't already, consider subscribing, hit the like button, leave me a comment. Both those things help drive the YouTube algorithm to get me a little bit more exposure out there. So any of those things help me out a lot. Anyways, guys, thanks so much for watching.